All right. So today we're going to look at one-sided limits of derivatives. So we've already talked about this indirectly, and you actually had a homework problem where we talked about it more directly yesterday. Um, but here's the deal. If we want to find the derivative to the right of a, we can do it this way by taking the limit as h goes to 0 from the right. And to find the left-hand derivative, we can do the limit as h goes to 0 from the left of our difference quotient. And what happens is that just like with any other limit, if the limit from the left and the limit from the right are not equal to each other, then the limit at that point does not exist. And therefore, in this case, if the left and right-hand derivatives don't agree, then the derivative does not exist at that point. So, for example, we want to show that this piecewise function, f of x is equal to x squared for x less than or equal to 0, and 3x for x is greater than 0, has left and right-hand derivatives at x equals 0, but has no derivative there. Okay, so let's start with left-hand derivative. So the left-hand derivative at x is equal to 0 will be the limit as h goes to 0 from the left of, since we're coming from the left, we're going to be using this part. So that's going to be 0 plus h squared. Now, be careful, there's a lot of zeros in this particular problem. This 0 is because we're looking at x equals 0. This 0 is part of the definition. Minus, how do I calculate f at 0? Substitute it into which one?
X squared.
The x squared. So minus 0 squared, because this says equal to 0, you got to use this one. All over, and again, you don't have to do that, I just like to. It's a slope.
I know.
It's the change in y over the change in x.
I get it, but like when I put it there, it throws me off.
Yeah, you don't have to. It's just that I'm always going to do it. So this is going to be h squared in the numerator, and that's it, over h in the denominator. So that'll be the limit as h goes to 0 from the left of h, which is what? 0. So this has a left-hand derivative at 0. Well, now let's do the right-hand derivative. At x equals 0. So that'll be the limit as h goes to 0 from the right of, if we're doing the part that comes from the right, which of these two branches are we going to want to use? the 3x. So this is going to be 3 times 0 plus h minus, we want f at 0. I'm sorry? Exactly right. Minus 0 squared. And this is a mistake that a lot of people make. In this particular one, it doesn't change your answer at all. But on some of them, it will greatly change your answer. So it's at 0. Remember that it's f of a plus h minus f at a over h. So we have to use the squared part.
Okay.
That's going to be a big deal on some problems. All over 0 plus h minus 0. So that'll be the limit as h goes to 0 from the right of 3h over h, which is 3. So the right-hand derivative is 3, but the left-hand derivative was 0. Therefore, f prime at 0, which would be equal to the limit as h goes to 0 of f of 0 plus h minus f of 0 all over h. Morning, gentlemen. Does not exist.
Let me know if it starts where it's not cooling.
Is it close right now?
It's reading perfect right now.
Okay.
But just, I think there were some issues yesterday. So
Gotcha. This limit does not exist. Now, real quickly, graphically, what's going on there? Well, that one I'm not even going to use my calculator for because it's easy graphs. Y is equal to x squared for x less than or equal to 0 is that left-hand side of a parabola. Really? Y equals 3x is just a line with a slope of 3. So what's happening is as we're approaching 0 from the right, the slopes are all 3, aren't they? And as we approach 0 from the left, this gets to be close to being a horizontal tangent, which has a slope of 0. But since they don't agree with each other, the derivative at 0 does not exist. Now, you bring up a really good question there, though, with the jump discontinuity. Just real quickly, erase all of that. Let's say that you had something that had a jump discontinuity. Let's say we were trying to find the derivative of something at 1. And at 1, this is equal to 1. And over here, oh, let's just say that it's a line like that. And over here, it's a line like that. Okay? Now, I drew those specifically so that these lines look like they have the same slope. And occasionally students will go, oh, well, the slopes from the right and the slopes from the left are going to match each other. Au contraire, mon frère. Not so fast. Because what's happening is over here, where we're approaching this point, the slopes are whatever the slope of this line is. But on this side, remember, the slope is from f of 1 plus h minus f at 1, which is down here. So the slopes are going to look more like this. right? Because we're joining a point on this side to this point, not to the hole. As we get closer and closer to the hole, this line is going to become closer and closer to vertical. And what's the slope of a vertical line?
7. 0. 0. 1. No. It's like the x.
Yes, what is the slope of a vertical line?
Undefined.
Thank you, it's undefined.
Huh.
The slope of a vertical line is undefined. So what's going to happen is your left-hand derivative is going to exist here, but your right-hand derivative is not going to exist. Therefore, the derivative at this point does not exist. Okay? All right. Let's quiz.